There you go. Thank you.
All right, ready to go?
Yeah.
Okay, so my name is Bob Weiss. We're going to talk about password cracking tools. So who am I? Founder and owner of Password Crackers Incorporated. Been doing this for about 13 years. I'm a crypto guy, so do a little bit of math. I understand sort of how cryptography works at the more primitive level. I'm also a DEF CON goon, and I will be out there. We got 12 days. Who's going to DEF CON?
Woo!
Not that many people, but yeah, 12 more days. Get your liver ready. Let's see what else. Wanted to thank the organizers of Ohio Security InfoSec Forum. Thank you very much for having me today and for treating me and dinner last night and stuff. Thank you very much.
Thank you for coming.
Also wanted to thank the sponsors. We went over the whole list earlier today, but to the sponsors in the room and the people who are helping to support the refreshments and everything else, thank you to all of those guys. And as attendees, remember our sponsors, right? They're paying for this and they're making this happen. Let me talk a little bit about, well, DEF CON. If you haven't been to DEF CON, it's a fantastic experience. It is this thing scaled up pretty significantly, right? You're going to see a lot of very high-end talks, right?
Stay away from Bob, he drinks too much.
Right, you drink a lot. There's going to be 5 tracks going on all the time for 3 days. You can't see it all. You're talking about 15,000 of your fellow hackers in a hotel. It's a tremendous experience. So I highly recommend that you think about doing those types of things or attending some of the other cons. Another thing, and anyone who wants to talk about DEF CON or learn something about that or has any questions about the experience, feel free to ask me at any time.
I wanted to get a badge earlier, but
you can't get a badge early. It is cash on the barrelhead. You got to wait in a huge ass line on Thursday morning, unless you're me. So it's good to be me.
Or a speaker.
Right, or a speaker, right? So you could speak, and which leads right into something else I wanted to say. You get more out of any kind of community, particularly like this, if you participate in it. So for those people who are new to Ohio InfoSec forums, or maybe haven't spoken before, keep a list. Step 1 is make a list of things that you're interested in that you might want to give a talk about someday, and just keep that. I have a little text file on my computer. Oh, that's interesting. I might want to do research on that. And think about, becoming the person on that topic. Think about, it's like, hey, maybe I could give a talk one of these days at Ohio InfoSec Forum, or maybe I could work up and speak at DEF CON or whatever. And there's a lot of smart guys. It can be very, very intimidating when you see some of the other speakers out there. They go, oh, I could never do that. It's like, but everyone knows something, right? So you can become that person. And I encourage you to start now thinking about where you want to be and what you want to be doing 5 years from now, etc. You could be that speaker, you could be the guy up here giving the talk, or at DEF CON, or one of the other hacker forums. Start thinking about that and thinking about what you can contribute and how you would get from point A to point B. So let's see, thank yous, a little bit about me. Big week in cracking. I tweeted out at the end of last week. Last week we had 3 breaches. Anyone know which ones they are? Yeah. Not the ones on this list. The previous week. LinkedIn. Who else? Who got hacked?
Yahoo.
Yeah, that's up here. Yahoo Voice.
Hotmail, Google.
No. LinkedIn, eHarmony. And what was the other one? Last.fm. And whenever that happens, people are always like emailing me and tweeting me and calling me. It was like, oh, do you have the file? Did you do this? Did you get that? We need this stuff. And I was like, I'm trying to get work done and prepare for this and all the rest of this stuff. At the end of the week, I was just like, it's like, seriously? It was like, please stop already. It was like, so we ended up with those 3 breaches, and then this week happened. Right? FormSpring, Yahoo Voice, NVIDIA, Fandroid, Billabong. I can't even keep my boss appraised of the hacks. They're happening too fast, right? So I don't know, maybe we're just in the middle of like we had a big run, you know, 2 bad weeks in a row or something like that. Maybe it's accelerating. I don't know whether it's one or the other. We won't know until we have some perspective on this and we can look back and say, you know, was this just the beginning of this big ramp up? Yeah, FormSpring took up like an entire night working with a bunch of people. Like, we heard that it got hacked and it was like, yeah, where's the file? Nobody knew where the file was. Then finally we found the file. And FormSpring had already put out a press release saying, yeah, well, the hashes got dumped, but don't worry, they were SHA-256 and they were salted. So we're good. So the file, we get the file, and they're SHA-256. I'm like, where's the salt? No salt. I'm like, you know, it's not right. And then someone said, oh yeah, they are salted, they are salted. So it turns out, I'll tell you a little bit, I can tell you now what they did. First of all, let's talk about a little terminology. Who knows what a hash is, how it works? Everyone knows what hashing is, okay? Can you decrypt a hash? No. You cannot decrypt a hash. You cannot take a hash and reverse it back to the password, okay? You break hashes by taking a password, hashing it again, and then saying, is it the same, right? So you can keep attacking that hash and seeing if you can create something that matches the same. But you don't take the hash and decrypt it. Hashing is a one-direction algorithm, goes one way. You cannot decrypt it, okay? So FormSpring comes out and people were matching them up, matching the passwords up. And turns out what they did is, in terminology we'd say SHA-256, open paren, salt, comma, pass, close paren. So they appended something to the password, or prepended something to the password, and then they hashed that whole thing. So all they had in the system was the hash. What they prepended was a 2-digit number. So it could have been 00 to 99, right, or 100 possibilities. And I don't know if they stored the 2-digit number or not on the FormSpring server. They don't need to, because when I log in and type in my password, they can just take that password and they could try all 100 possibilities, right? Because there's only 100. So that's what the crackers were doing. It's just, you know, it's like, well, we'll run all of our brute force attacks, but we'll prepend 00, then we'll do 01, 02, 03, and we'll try all those possibilities. And they broke a ton of those. Yahoo Voice, you didn't need to crack, okay, because that was a SQL injection, and it was all plain text. And the other 3, I don't have the files for yet because they were yesterday and I was on a plane. But so this is a big, very time-consuming thing for me. It interrupts my work. But the other thing to take away from this is, hey, you know, these attacks happen all the time, right? Passwords are dumped. So I think there's the next slide. Yeah. So what are the takeaways? FormSpring guy thinks he's a genius, right? I've got create salted SHA-256, right? Because I prepended a 2-digit number. You're not a genius, okay? You just screwed up, right? But you don't know. And what you need to learn in crypto is the more of crypto you know, the more you learn never, ever, ever create your own crypto. Right? So that should probably be the last slide, last sentence in this presentation. But never create your own crypto. And never, for you guys, never reuse a password. Okay? If I create a password on Yahoo Voice, don't use it on my bank account, don't use it on Google Voice, don't use it in other places, because all it takes is one of those sites to get compromised. Your password is now out there. And always on these breaches, you can assume that the hacker who hacked Yahoo Voice or FormSpring took all those user credentials, tried logging into their Facebook, their Gmail, their PayPal account, on down the line. Probably just ran a script to try that password for all the different things that they could get into that could store a credit card or have money in it or had any value. And then when they're done, then they release it and they say, oh, we hacked FormSpring. They're not doing this as a service to the community. So if you have that same password, that's coming out, and that's going to get released, and that's your real vulnerability, right? So who had, prior to a week ago, ever heard of FormSpring? 0. Anyone ever heard of Yahoo Voice? Oh, we had like 5 people. Okay, yeah. So I'd never heard of Yahoo Voice, you know, and that was pretty much the reaction from most people. I think is like, Yahoo Voice. What the heck's that? And it's like, you know, maybe you care about whether or not you lose your Yahoo Voice account, but your big deal is whether or not that multiplies to all of your other accounts. And they will try versions of the password. So if your password is password -Yahoo, right? And I'm going to log into LinkedIn. Obviously, I'm going to try password -LinkedIn. Right? Not patently idiots. We figure out, you know, oh, I see a pattern going on here. So what this may mean also is the end of passwords, right? So this has been talked about probably for a couple of years now, and it's going to take a couple of years. But from my perspective, in a very large enterprise, that's definitely what we're talking about. And when I say the death of passwords, what that means in practice to you is you're still going to have a password. It's just really not going to be what we use to authenticate who you are, okay? Or to make sure that you are who you say you are and that you're supposed to be here. It's more going to be sort of a backup. Right? So think about, you know, it's like in order to log in, I need to use my YubiKey or my multi-factor authentication. I've got my, and this is the dongle for the clicker, but, and I've got my my 2048-bit private key on here, and this is my authentication. But in order to tie this so that you can't use mine, right, we put a password on the key, right? So we'll put a password on the key as well. And then there's a password on the site, okay? And those have to be different passwords. So to log in, you need the site password, which could be weak. It can be password123, we don't care. And you need this key. But if you lose this key, I can regenerate it using the password. So now with the password, you can log into the site which sends you a new key, and we'll de-authenticate this one, we'll ship you a new one in the mail, you'll go to another site to activate your key, plug that in, activate, create a new password, and now you're sort of reset up. And I'll run that system through the password. That's the only thing that I'll use the password for. But basically, passwords effectively are going to be dead from the perspective of you proving something you know back to the system to say who you are. Probably not going to be, I would suspect that we're going to see that dead in 5 years. And at least for anything that's important, right? So, I don't know, is Facebook important? Probably important to some people. Not to me. But you know, I'm thinking banking or anything with money, anything with medical, anything with what you'd call, you know, personally identifiable information, PII, corporate intellectual property, all that stuff will be protected with some sort of multi-factor authentication probably in 5 years.
So you're going to have 9,000 little keys to...
That may be. That may be.
Yeah, all those keys on your belt.
Right, and it may be that you know it would not be hard for someone to effectively create a persona for you, give you a private key, and then once I have literally anything in the crypto world, once I have anything I can hang on that is you, I can use one public key to generate another private key that's unique for my banking experience, use that private key for the bank, and then give you now the ability to revoke keys and change keys and manage keys. And that's really simple, okay, and totally secure. So that's really very easy, and none of that stuff takes up a lot of space, right? So I can put it all on the USB stick, and it's really not that big of a deal. So I have no idea, obviously, what that architecture is going to look like going down the road. But I do suspect that people's tolerance for breaking passwords is coming to an end. There's an outcome to some of the stuff that we'll talk about today in terms of breaking passwords and creating or figuring out credentials. The outcome is, if that becomes too easy, and it is relatively easy, people take action, right? And you don't just sit there and say, oh, well, that's it. There sort of is an opposing force. So when Raphael says, it's like, hey, my job is I'm red team. I break into stuff, and someone over here asked the question, it was like, well, what's the defense, right? Like, hey, not my job, right? We don't do that. But somebody does, right? And defense guy eventually comes around to saying, well, okay, I understand here's a problem. Now we have to have a solution. We have to have a response to that. So you're never in a static environment. And same thing with the passwords. Passwords are obviously are going to be too easy to break. There has to be a response on the back end, and there are tools. So there is a reasonable expected response that you can have. The question is just really, what is the public's tolerance for stupidity and for lack of a security before they demand it, right? And I don't know the answer. We'll see where we are. All right. So let me talk a little bit about the goals of the talk today and kind of where I want you to be. I meet a lot of hackers who don't know crypto. They don't know how to break passwords. So what I think is they kind of become password tool collectors, right? Oh, hey, look, a big rainbow table. Let's download that. I don't really know what it does, but it's really a big file, so it must be important, so I'm going to collect it, right? I get that. And then, oh, here's a word list site. Let me strip all that stuff off. I need that, right? And they get all this stuff. It's like they're not really doing anything with it. So I want you to know sort of, well, what are the tools? How do they work? I don't necessarily care whether you use them, but I want you to feel comfortable enough that you now don't need to collect it, right? You say, oh, I know what that is, okay? It's not rocket science. It's not something that's shrouded in mystery. So okay, I can get that if I expect to use it, or I can leave it alone and I don't need it because I know what that does. So I want you to be able to go out today. You should be able to download all the tools, get all the different pieces of data you want, break some passwords, and hopefully not break into any systems. Play with the hash files you find on the internet all you want. Don't take that data and try to break into someone's Yahoo account, right? That's where you're breaking the law. But learn about how the systems work. You should be able to do all that by the end of the talk today. I forgot to mention, feel free to interrupt me at any time. I don't need to stand up and talk by myself for an hour. So if you have any questions, raise your hands, just yell out, I don't care. This should be interactive, and that would be great if we're talking. So first thing I think we want to talk about is different types of passwords. Different type of password, different tool, totally different approach to what you're going to be doing with it. So we've talked about hashes. I think you guys seem to understand hash is a one-way function. We can take something, create this sort of unique identifier. It's a very complex, unique identifier. Does everyone understand what salting is and why we do salting?
No.
Okay, so we'll talk a little bit about what a salted hash is. If I create a password, and we'll just use password, or 1, 2, 3, 4, 5, 6 as an example, and I create a hash of that, either the most popular hashing functions, let's say, are MD5 and SHA-1 right now. If I create the MD5 or the SHA-1 of the word password, I'm going to get this long string, and if you then create an MD5 of the word password, you get the exact same string. So if I have 1 million users on my system, and 2 of them have the same password, they will have exactly the same MD5 string, they'll have exactly the same SHA-1 string. And that's in fact what we're using when we break the password, because we don't take the string and reverse it. We take the word password and we MD5 it, and then we compare, right? So if you've got 2 users on the system and they have the same password, they will also have the same hash if it is not salted. What we do with the salt is we say, that's unacceptable, right? We don't want them to have the same hash. So at the time that the hash is created, we will create a random value, a salt value. The password comes in, and there's a couple of different ways you could apply the salt. You could prepend it, which is what FormSpring did. You can append it, put it on the end, which is, I think, what most people do. You could XOR it. Okay, you could XOR it into the password. Theoretically, you could stick it in the middle of the password. I've never seen anyone do that, but there's no reason why you couldn't. So I'm going to take, let's say, 10 bytes of data, completely random, stick that on the end of the password, and then I'm going to take the SHA-1 of that. Okay? Now, when I do my authentication, I need to store the SHA-1 value that I just created, and I need to store the salt that I just created. User comes in and wants to authenticate, says my password is, and types in password. I go to the database for that user, I take their salt, which I've stored in the database, I stick it on the end of password, I SHA-1 it. If it matches the hash that I've stored, then they are authenticated and they are the correct person. They've provided the secret question. But 2 users now who have the same password will have different salts. So they will have different salt and SHA-1 hash combinations in the database. Let me ask you another question. Are we all clear on why we're not storing the passwords in the database? Yahoo Mail, Yahoo Voice, call your office. We're not storing the passwords in the database because what we don't want to happen is what happened to Yahoo Voice, which is database gets compromised and everyone's passwords are just out there. So we're trying to make this difficult, and the way we've made this difficult is by storing only the hash in the database. But because we have a process for being able to take the password, compare it against the data, and verify the user, that's how we can get back, right? So salting means that 2 users in the database will have different hashes. 2 users with the same password would have different hashes. But the users never see the database, right? And ideally, no one ever sees the database, right? So why is salting important, all right? Take a breath a second. Oh, by the way, when I do this, I haven't done this that many times, so I'm still nervous when I'm talking to you guys. So anyway, maybe that comes out, maybe it doesn't, but just as I say, anyone can put up with this for an hour. So again, I encourage everyone to talk. Yeah, go ahead.
I'll just throw up a question to
Sure.
break it up for you.
Go ahead.
I understand the salting password hash. Why wouldn't, or is there a format that says the MD5 and the SHA-1 algorithm, encryption algorithm, has to use the same value to encrypt and create the hash, or can those also be randomized by enterprise?
So we're typically when you do the salting, where the system is going to create a random value at that moment. So everyone in the system has a different randomly generated salt. So you have 1 million users in the system, got 1 million completely different random salts. If 2 users, because they're random, accidentally get the same salt, which would not be likely given the key space of the salt, right? Even if I've chosen millions of these things, the probability of 2 of them matching is not high, but it's possible. That's not an issue, right? What are the chances that those 2 users have the same password? Doesn't make any difference. And even if they did, and I ended up with 2 hashes with 2 salts on the same, which is very unlikely, microscopically unlikely, still not an issue. It's not a problem, say, unless something goes wrong. But ideally, no one's supposed to see all of this, and authentication works because I can present the password as something I know. We have a way to add the salt. And check the password, check it against the hash. You are who you say you are. You can come into the system. But the key reason why salting is important is if something goes wrong. If that database gets released, which it shouldn't, right? These breaches should not happen. That's what John was talking about. That's what John and I were talking about last night, what John talked about in his thing, right? Database administrator or someone in the security department of this company has screwed up, right? And that was your first fundamental problem, right? Somebody made a mistake, and now the hash file is out there in the real world. If it's not salted, I can pre-compute all the unsalted hashes, right? I can run those in my spare time, and they have already been run by lots of people and built into a rainbow table. So I have pre-calculated months and months of processing time into a rainbow table, which we'll talk about a little bit later, because it's unsalted. I know all we're doing is straight MD5 or straight SHA-1 or straight SHA-256 or NTLM, any different formula that you want to use. I can pre-calculate that, and I can store it on my hard disk in a very compressed way, and I'm good. Salting prevents that. Salting prevents me from being able to do that. Yeah, go ahead.
How are the salts stored?
The salt can be stored in the same database. It does not affect the security. For instance, let's say FormSpring had actually done something secure and used a fairly long salt. And a SHA-256 is how long is that? Is it 64 bytes? I think that the hash coming out is 64 bytes. I can salt that with something that's 64 bytes. I can salt that with a random SHA-256 hash. I can salt it with something longer. Doesn't make any difference, really, right? As long as it's, let's say, more than 2 to the 56th, right? It has to be sufficiently complex that it's not easily guessable. But if I know that you're salting it with a 2-digit number, I could just build 100 rainbow tables, right? And then I've pre-calculated that. That is not sufficiently complex. So the key is that the salt has to be complex enough that I'm not going to build rainbow tables for all of the possibilities. But salting takes care of that, that pre-calculation part. So we're talking about different types of passwords. You're going to use different tools at different times depending on what you've got. So if you're talking about unsalted hashes that are supported by tools, so it's a standard hash. It's SHA-1, SHA-256, MD5, NTLM, et cetera, et cetera. It's supported by the tools and it's unsalted. That's going to be relatively easy to do, and we're going to have one strategy or a series of strategies for dealing with that. Unsalted hash is not supported by tools. So let's say, for instance, here's my encryption, my hashing algorithm for your password. You present the password, I SHA-256 it, I take that SHA-256 and I MD5 it, I take the MD5 hash and I SHA-1 it, and then I take that SHA-1 hash and I SHA-256 it. And I store the SHA-256 hash that comes out of those 4 hashing steps. Well, there's no tool. No one wrote a tool for that, right? I mean, it's a fairly straightforward series of obfuscations that you've done. And what I'll see when I go to break those passwords is I'll see a whole bunch of SHA-256 hashes. But I wasn't really SHA-256ing the password. I went through these multiple steps, right? Now you could write a custom tool that would do exactly that. So if you go into an environment and someone says, oh, this is our hashing algorithm, then I can build that into a tool and I can customize the tool that's going to do that. But my options for doing that are fairly small today. I think one of the weaknesses of where we are with tools today is that they're not very customizable by me. So they're pretty much pre-built. So they're not modular, and there's no APIs for them, and there's no plugins, right? So I can't drop in my own algorithm into John the Ripper. John the Ripper is hard-coded with a series of algorithms. Hashcat is hard-coded with a series of algorithms. Each of these tools are hard-coded. So there's not a lot of ways for me to customize that. That's a pretty easy thing to fix if you're the writer of the tool. So I suspect that that's going to get fixed within the next year. The other thing is, I'll get to the Crack Me If You Can contest, but at DEF CON. But the Crack Me If You Can contest at DEF CON tends to be specifically formulated to push the envelope. They put things in the contest in order to goose the tool writers to change the tools. So if I was the Crack Me If You Can contest guys, and I know them, I would be writing some of these unsupported hash algorithms into the contest in order to make the tool writers fix the tools so that I can say what algorithm I want. And it could be a drop-down menu. I say, hey, I want you to SHA-256 the password, then MD5 it, then SHA-1 it, then SHA-256 it, and then just drag and drop each of those pieces in, and then store this, and that's what I want to compare against the hash value. So it'd be relatively easy to do, and because it's easy to do, I assume it'll get done. But you need to know whether your hash is something that's supported by a tool or not supported by a tool. Same thing with the salted, right? Typically with the salted, you're going to see a salt. The Formspring thing was very unusual and epic fail. But typically you're going to see that salt in the database. Now that tells you you can't use rainbow tables, is pretty much, or you can't use any kind of pre-calculation, but you can still run through the brute force. Challenges. So let's talk about what a challenge password is. We have a user has a password, and I have already created a hash of that password on my system. So the user and I have this shared secret. The user has a password. The password can be changed into a hash. I have the hash, so we can compare. Those are good. That creates a login situation where I'm going to take the password hash, I'm going to send it over the wire, and typically I would do that. Then Raphael's going to capture that. It's a lock, and we're going to pass the hash. We're going to replay that. So there are a lot of systems now that will do what's called challenges. So we now have a shared secret, and what I tell you is, what I do is I send back to the system. I say, here is a very long string. It's let's say again a 64-bit string. And I want you to take this string and I want you to XOR it with the hash of your password, and I want you to send me the result. So server sends the challenge code. Client responds back with the XOR of the hash and the challenge code. So the hash never moves, the hash is never passed over the wire. Much more secure system as long as we have already established a pre-shared key. Yeah, go ahead.
You said you would see the salts that actually show up. Were you saying that you would see them in the dump data, or would you see them somewhere else?
Yeah, typically it'll be hash and then colon salt. So you'll see for each user, you would see two pieces of data.
So it's two separate fields.
Fields, correct. Right. So in the challenge, so you see a lot of times when you're talking over the wire, you'll see that, again, as long as it's pre-shared already, you can see that challenge login going back and forth. And now two pieces of data are being sent back and forth, which if Raphael captures them, they don't do them any good. Because the next time, I'm going to send you a different challenge. Right? So the fact that he knows what the response was isn't going to get you anywhere. Now, I guess if we only XOR'd it, then you'd be able to un-XOR it, right? But so we could do some operation there so that you can use the hash of the password as a key to do something else, and so we should be able to make that secure fairly easily. So challenges, you're also not going to be able to pre-calculate. It's effectively like a salt. Application passwords are going to be like Microsoft Office, Excel, Word, zip files, RAR files, etc. They all have their own way of doing things. Adobe Acrobat 5.0 has passwords, or all the versions have passwords. 5.0 has a more secure password. But so in those, you're going to see some sort of password cracking software that's application specific. And they are typically all different, and that's one of the things that I started doing those 13 years ago. But right now my company supports about 80 different applications. That's probably most of them. But you know, occasionally we'll still see something that somebody comes up as a one-off and says, you know, do you have a password cracker for this? And we have to develop something custom, and they usually don't want to pay for it. But those typically are not going to be supported by John the Ripper, Hashcat, etc., by your other tools. And then logins. What we're not talking about generally is you got a login box and you're going to try every possible password. That's not what these tools do. They typically are focused on you already have the hash. You've brought that out of the system. And if I have a hash, I can bang up against that thing. Well, just with a CPU, we might be doing 8 million tests per second, right? If I'm running it in a GPU system, depending on how many GPUs I have, you could be doing 10,000 times that, right? So 80,000, was it 80,000 million? I don't know how big that number is. Tests per second against that password. So I can do this massively fast, right? Logging in, right? I don't know, once every second, 1 a second, and I can multi-thread it. I can run 30 sessions, right, on one PC, all trying to log in, right? So it's 30 tests per second. To me, that's noise. You're never going to log in like that, unless, again, you know something about the system, or they told you up front it was a PIN number. Well, then you could do it, maybe. But this is not what we're talking about generally. And there are pieces of software that will brute force logins, right? A lot of people can use like, can you brute force my my Gmail account or my Yahoo account or something like that? Yeah, there's tools for that, right? You can download a tool that will attempt to hit your mail server and try every possible password. It will never succeed, right? Because you can't do enough of them fast enough. But theoretically, it's possible. And again, it also theoretically assumes that some database administrator on the other end is not watching that traffic, because it's going to be very, very noisy. All right, so what are the key tools? Starting off point, you want to sort of know what different pieces of software you're working with. John the Ripper is probably the main one. There's a new version of John the Ripper out just in the last 2 weeks. I haven't even downloaded it or used it yet. But the two big things that it now supports are Microsoft Office application is now built into John the Ripper. That's huge. Previously you had to pay if you wanted to get software that would break Microsoft Office passwords. But it's now built into John the Ripper, and that's also a big deal because it's very, very hard to break the new Microsoft 2007 and 2010. Those are serious Microsoft Office passwords. Earlier, fairly trivial. And the second thing John the Ripper new version does, and this is the jumbo version, is it's GPU accelerated. So one of the big problems with John the Ripper up until last week is much, much faster to do the stuff in the GPU, and John the Ripper doesn't work in the GPU. So everyone was like, oh, I need to go get another tool. So now John the Ripper works in the GPU, and that's a huge advance, and again, just in the last 2 weeks or so. Hashcat is sort of the biggest competitor, and there will be at DEF CON in the Crack the Hash Challenge, there will be a John the Ripper team, and there will be a Hashcat team, Team Hashcat or whatever. And so that's the new sort of up-and-coming competitor, mostly focused on cracking hashes as opposed to application passwords. And then they have multiple versions out called OCL Hashcat. If you just go to the Hashcat website, there's links to the OCL Hashcat. But OCL stands for Open Computing Library, okay. And that is the GPU accelerated, the open version of the GPU accelerated software. So when we're talking about regular Hashcat, we're talking about the non-GPU version. When we're talking about OCL Hashcat, we're talking about the GPU version. They are exactly the same thing with that plugin, with the OCL plugin. Cane Enable is particularly good for the wireless and the pass the hash type stuff. Also does a lot of the other regular password cracking. Inside Pro is a commercial product, but it's not very expensive. I think it's like $50 or something like that. But Inside Pro supports a much broader range of all the different algorithms. When I say, it's like take the append the salt to the password or prepend the salt to the password, do salt pass MD5 and MD5 result. Inside Pro supports a lot of those types of things and ends up with about 200 different algorithms that they support. So if you were a system administrator and you wanted to try to obfuscate things by coming up with some hash of the hash of the hash algorithm, you'd go get the Inside Pro list, right, and make sure you don't do any of those. Because those would be in a supported tool that I can easily buy and download. CryptoHaze Multiforcer is right now the fastest one out there. That's a GPU accelerated product, and speed-wise, that's the one you want to pick if your algorithm is on their supported list. But they have a much smaller supported list than many of the other products, and their rules are not as compatible. The application-specific tools, Passware, Outcomesoft, typically those are commercial products. There are rainbow tables, which we'll talk about a little bit more, and there are online rainbow tables. So as a for instance, if I have a particular hash, let's say I've got one hash, right? I've got this MD5 and I want to try to find out what the password is. Easiest, fastest way to do that is go to MD5 online, put the hash in, and it'll tell you what the password is, right? And it's just looking it up in its rainbow table.
If it knows it.
If it knows it, right. And it may return, I don't know what this is. There are a lot of MD5s and a lot of possible passwords that it could be that it will not be in the database. But if you're allowed to take your hash, if you're in an environment where you have a hash and you're allowed to send it out, sending it out and putting it online is really no problem. And giving someone a hash of something, you're not really giving them any data, right? They're giving you data, or you're giving them nothing. So there are a lot of online resources. Now, if you're in a government, military, or an intelligence situation, and you've got a hash from a target or whatever, they're not going to let you go to a public website and put that data on the website in order to figure out what it is. So you may be in a situation where you're not allowed to do that, but it is certainly a possibility. It's a resource that's out there. And if you can't use that resource, then you go up one. You're going to do your own rainbow tables. You're going to download a bunch of stuff, and you're basically going to build your own internal way of doing that. All right, I want to talk a little bit more about rainbow tables, but let me just go backwards. We didn't talk about hardware. I want to do that. There are three levels of hardware that we would look at or use for this type of work. One would be just a CPU system, and obviously faster CPU, faster braking, faster speed. You're going to break more stuff faster. So i7 with a lot of cache and a lot of memory is going to run faster than my Pentium. Okay. But within that, you can look at CPUs and say that gives me a certain amount of capability. If you are going to be using a GPU-enabled tool, having that GPU card, and what is it? GPU card for desktops, roughly a $150 item. Let's assume roughly $150. That is going to give you about a 10,000x speed up, one card, right? Drop two cards in, 20,000x. So it is massively faster, as long as you're using a GPU-enabled tool. So you might find that the hash that you're trying to break is supported by John the Ripper, in this version. Well, now John the Ripper is GPU enabled, right? But you might find, let's say it's John the Ripper, but it's not supported in the GPU. Well, then having the GPU doesn't get you anywhere, right? But if you are trying to break something that is supported by one of the GPU tools, you definitely want to go get the GPU tool, use that version, and you want to do it in the GPU. It's going to be massively faster. The next step up is not the kind of thing that anyone in the room is going to have. But you can also use an FPGA array. So you would see that definitely at the intelligence agencies. You would see FPGA arrays being used in the military for anything that's a serious target that they really want to throw something at. But basically, you get a little box like this, and it'd be about $5,000. Sorry, go ahead.
Say that again, what is it?
FPGA, which stands for Field Programmable Gate Array. It's basically a little chip that we can program and reprogram in real time. We're actually programming the chip to do different things. So basically, it's a chip with just a massive array of gates, and we can, on the fly, tell it how to make itself a faster chip. So we're effectively creating a customized chip just for cracking the thing that we want to crack in real time on the fly while we're doing it. So it's really, really fast, and it gives you, on a per dollar basis, a huge step up. But the entry-level box for that thing is pretty much a $5,000 box, and in big customers, you'll see them have racks of boxes. Yes.
How is the per dollar stacking up though between that and like say getting a bunch of high-end graphics cards and throwing in? I have a buddy who runs a passive cracking service, and it's great to walk in there on a winter day and stay in that room, warm up. But how does it compare, price-wise?
So at the high end, right? And most of us aren't going to be able to get into even the low end of the FPGA, but at the high end, you're looking at processing power per dollar, and the FPGA is going to be right now less expensive. So it's going to be a more efficient way to apply dollar resources than buying a whole bunch of GPUs.
But the lower end of the scale, for like us, we'd probably be...
Right, well, so even to get one FPGA box, we'd already be past 30 GPUs, right? And so we don't even get to being able to afford the first FPGA box until we're already thinking about something with 30 GPUs. So that's a pretty high-end system already. And the other problem with the FPGAs is you need software to run that. So typically the software that runs that FPGA is customized for certain very specific hash types or types of calculations. So if they don't support, if your FPGA software manufacturer doesn't support your particular hash type, now you have a box that doesn't do anything. Right? Now you can always program it yourself, but at the FPGA array level, that's really complex. I don't know how to do that. So again, you always need to sort of look at what's your mission, what are you trying to get to, what type of passwords we have, what are the matrix of tools that we have at our disposal, what type of hardware do we have on it. Remember also with the GPUs, you can put up a Amazon processor instance, and you can attach GPUs to your Amazon instance. It's virtual environment, so you can attach any number of virtual GPUs to your virtual instance. So you can immediately create a box with 100 GPUs on it. Over the long run, Amazon is more expensive than buying hardware. Yeah, go ahead.
Do you know how these GPUs are attached?
It's a virtual GPU. So
because when I played around with the I/O throughput on Amazon, was always the bottleneck. That's why I'm asking.
what was the bottleneck?
I/O.
Oh, so you mean from the instance to the GPU?
I mean, I played around with the storage. There, the I/O was pretty poor back then.
Right.
2 years ago.
Well, with password cracking, your hash file is a relatively small piece of data. So you're just going to stick it on the instance, and then it's all about the processing speed. And so typically you're not talking about something that's I/O intensive in and out of the instance or between the instance. Whereas once we fire this thing up, we're just talking about just billions and trillions and trillions of calculations occurring really, really fast. So the GPU typically is the way to go with that. Now, if you were going to be doing this over any sort of an extended period of time, whatever extended period of time that is, it would make more sense to buy it than rent it from Amazon. Amazon charges more over a period of time. But let's say, for instance, I needed an emergency response capability, and I wanted to have at my disposal a 100 GPU server, but I don't know if I'm ever going to need it, right? So I can build it out, I can put it up on Amazon, I can test it, I can get all my software running, I can test my GPU, I'm probably going to spend getting this thing up and running in Amazon time $50 or $100, right? And then I turn it off, right? And now it is ready to go when I need it. I can fire up a 100 GPU server. Whereas if I have to do that in physical world, I've spent $20,000, right, on a physical box that is sitting there waiting for me to do something on it. So if that's your situation, Amazon is an option, right? It's putting up a lot of GPUs, and you can virtually do as many as you want. You can sit back and say, oh, I have a little bit more time, let me scale it back to 10 GPUs. Or I want 100, I want 1. You can go back and forth. So you could do a whole bunch of cracking locally on your CPU and GPU system here, and then for the stuff that's left over, right, send that off to Amazon only afterwards, and only if you've got budget left to start to get the non-low-hanging fruit. But GPUs on Amazon is a possibility. But what I want you to get out of the GPU thing is that GPUs are massively, massively faster, right? As you think, it's like, oh, I spent $1,000 for this i7 box with all this memory and the hard disk and stuff, and the GPU is $160. When I'm doing this, though, all the speed is in that GPU, right? That is a 10,000x speed up versus the box by itself.
Technologies like Crossfire and SLI, have they improved password cracking at all or significantly?
I don't know what Crossfire is.
It's like SLI,
I think it's bundling two GPUs together.
yeah, 2 or more.
Right. So typically what I found is that when you're looking at the speed step up, the way to go is you don't want to get the newest one, right? Because you pay a premium to get the latest and greatest, and you don't want to get the oldest one because that's inefficient. You want to kind of be where most of the consumers are, where the prices have started to drop, and that's your most efficient buy at any given point in time. And it'd be better to buy 2 of the previous generation GPUs than to buy the latest and greatest. But eventually the latest and greatest is going to be the previous generation, right? So it's sort of where you want to be. And I always break it down to dollars, right? And it's like, how much processing power can I get per dollar? And I map that out, and that's the thing that I'm buying. But you could say, it's like, oh, I've got a little bit extra budget. I want it to be a little bit more portable, so I'm going to get the latest and greatest, and it's going to be a little bit denser. How are we doing on time? I'm not looking at my phone. I just want to stay. 12:30, and we have until when, Daryl?
Keep going, I'll let you know.
Okay. So let's talk about rainbow tables. Who knows what a rainbow table is? Who knows how it works? A few more hands go down. Okay. There are multiple. Okay, so rainbow table is we're going to take a series of hashes. We're going to pre-calculate it. Okay, so we're going to do the work up front. We don't even have a hash to look at yet. We're going to pre-calculate stuff, and we're going to come up with a very dense way of storing that. And so we're going to trade off processing time and storage, and come up with sort of a happy medium of something that we can store that saves us a lot of processing time, but not all of it, at the expense of using up some storage space. So I want to spend a couple minutes.
About 6 minutes.
We have 6 minutes to go?
Yeah, you can run over a little bit.
Oh my
You
goodness.
can run over a few minutes.
I want to spend just a minute telling you how rainbow tables work, because I think it's really freaking cool. So a rainbow table is we're gonna take a password. We're gonna take A, and we're gonna hash it, and then we're going to and we think we're storing this in a database. Then we take B and hash it and store it in a database, whatever. The database gets incredibly huge. Well, we can't do that. So what a rainbow table does, this is sort of the quick version, is that we're going to create a chain. Okay? We're going to take, there's a function called a regression function in a rainbow table. A regression function is take a password, hash that, use the hash as an input into the regression function. The hash is pretty random. It is a very random series of things. It's always the same, but it looks random. and use that as input in a regression function. The regression function's job is to take you back out into the key space. So let's say, as a for instance, I want to do all the lowercase passwords up to 8 characters in length. One of them is A. So I take A, I hash it, I take the hash, put that into a regression function, and the regression function gives me another random password, one of which is B, 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 B. It could be anywhere in that key space. And I then hash that, put that into the regression function, take the hash of that, put that in the regression function, keep doing this, right? And let's say I'm going to create a chain of 10,000 hashes. What I store is A, my very first password, and then I store the last hash. Now, if that's all you're storing is A, and the hash of some password that got created by the regression function going back and forth 10,000 times, and I want to look up my hash. My hash was, let's say, the 5 Bs, right? It's not in my list. It's not in my rainbow table. So it does not match. So the question is, how do you get from the hash that you're trying to look up, how do you find it in your rainbow table? Well, I know in my rainbow table there are 10,000 characters, there are 10,000 hashes in each chain. So what I do is I take my hash and I push that into my regression function. It generates a password. Password generates a hash. I check that hash to see if it's in the table. If it isn't, I keep doing it. I do that 10,000 times, right? At some point in the 10,000 times, if it's a good rainbow table and it covers the entire key space, or most of the key space, it will generate a hash. Let's say on the 7,000th try, it generates a hash that is in my rainbow table list. Aha, it's now in my rainbow table list. So what's this hash? What was the original hash that I got? What password is it? I don't know, because all I know is the beginning. It started off as A. So I go back, I take that, but I know that my password is now in this chain that got created. I take the A back, and I keep running it. I take the A, generate the hash, put it into the regression function, come back out. I keep doing that until I get the hash that I just looked up. Then I just go back one. That was the password. So this takes some processing time to process a hash through a rainbow table. There is a trade-off there. It takes some processing on the back end. It takes a lot of processing on the front end. It takes a lot of storage to store the table, but you're storing a relatively small amount of data compared with a table of all of the passwords, which would just be enormous and you could never afford to store all that. So that's a very crass, gross generalization of how rainbow tables work. Anyway, rainbow tables are not all compatible with each other. Rainbow Crack, which is the first one, creates a .rt file. The naming convention for the .rt files tells you all of the parameters of the rainbow table, the algorithm, how many chains there are, how many hashes in each chain, what the regression function is, what the key space is in the naming convention of the .rt file. Free rainbow tables did them one better. They're indexed, but they create a .rti file. Cool, .rti file, a little bit faster, completely incompatible with .rt. However, from .rt1, and then they came out with a new version, .rt2. So they have a tool that can convert from RTI2 to RTI1, RTI1 to RTI2, and both of those back to RT. So those are not compatible with each other, and they won't work with the same software. So if you previously downloaded free rainbow tables software, if the old version is working with .rt1 files, you need to go get the new version. You want to get the RTI2, cool, it's faster, but now you need to convert all your tables or re-download them, either way. And they're not going to be compatible with Rainbow Crack, but there's a way to go back and forth between all of those to upgrade the software and move back and forth. So if you've got a reason why you're using Rainbow Crack software, you can go from the RTI2s if you've got a good table. CryptoHaze is a GPU accelerated rainbow table. So free rainbow tables and Rainbow Crack, you run those on the GPU. They don't run it. You run it on a CPU. They don't run on a GPU. CryptoHaze runs in a GPU, much faster. Again, 10,000 times faster. Not compatible with any of the other stuff, and you can't convert between it. Right? So again, you have to know, what am I doing? do I have a GPU system? If you don't have a GPU system, it doesn't make any difference that you're running a GPU-enabled tool, right? It's not going to go any faster. But if you've got if you're trying to crack SQL hashes, CryptoHaze doesn't support the SQL algorithm. So you might say, oh, I've got a GPU, I got these SQL hashes. Well, CryptoHaze doesn't support that. So I'm going to go with the next best tool, which would be free Rainbow Tables, which does support SQL, and there's some tables available for that. And then try to find the best table, and then use the converter to convert back into the best one. You can always use the online Rainbow Tables. Online Rainbow Tables typically support the easiest versions of the algorithms, MD5, SHA-1, SHA-256, SHA-512, but you get into something like SQL or Cisco PIX, a little bit more exotic algorithm, you're probably not going to find much in the online. Now you either need to build your own table or you go download someone. We talked about how tables work. I was surprised that no one did this before, but I guess no one did. I have now collected all of the Rainbow Tables that I could find on my website at pwcrack.com. It's currently about 3 terabytes of data in torrent files. So the torrent files themselves are very small, but it will add up to about 3 terabytes of data. So you can get all that stuff off my site. I have 100% on all of those files, and I'm seeding them all, and I intend to keep seeding them all. So you can go there and get that stuff. You don't need to worry that it's going to go away. Again, that's good. You want to have Rainbow Tables. You need to download them in advance, but you need to know, am I downloading a CryptoHaze thing? Do I have GPUs? What algorithm am I trying to break? You get out of this collector mentality. It was like, oh, a resource, I'll just go collect it. Again, you can kind of figure out whether you need to, whether that's something that you need to get. Effective right now, there's a guy named CryptoHaze. There's a CryptoHaze torrents available on his website and on my website. We are seeding 100% of those for NTLM 6 characters in length, NTLM 7 characters in length, MD5 6 characters in length, and MD5 7 characters in length. Those tables have been on his website. They are also on my website. They're available now. As of last night, I now have, and I am downloading 8 character NTLM files. So that is something that, let's say, the general public has never had available as a free resource prior to today. And as of last night, it's like, as of today, I have about 1%, right? That 8 character file is going to be a 1.2 terabyte file by itself. So that's going to take me from the 3 terabytes up to the 5 terabyte range. Go ahead, Adrian.
Now, if you have the 8, does that basically cover the range of the 6 and the 7 also, or does it only do exactly 8 characters?
I'm not positive.
Okay.
Typically, you'd think 8 covers everything below. You don't need to get the rest. And part of the reason for that is the additional 1 through 7 is extremely small relative to the 8, right? So that it wouldn't really cost you anything to include that in there. But maybe you want to focus and get the other files as well. Certainly, if you were doing the testing, if you had a password and you didn't know, I would want to run it through the 6s first, then the 7s, and then the 8s, just because the processing time is going to be enormous on the 8. Right, it's going to take you longer to do it because it's such a big file. But anyway, so you guys should be aware that was a significant advance that is happening sort of right now. No one's had 8 character NTLM files unless they paid for it, right? And that's going to be available for free. I will put that on my website and add that to my website as soon as I have 100%. And that could take a couple of weeks, right? It's going to take a while to get 1.2 terabytes, but that's moving. What? It's NTLM. I think MD5 is going to be coming shortly thereafter. As soon as he already has, CryptoHaze already has the MD5. What the problem is, he's got it on Amazon, and I/O costs him a lot. That wasn't my first thought on the choice of word. He pays a lot of money for that, so he doesn't want to serve it out to the community through Amazon because he's going to be paying for every byte. and it's too big a file. It's going to cost him too much money. So I said, hey, look, let me hook you up with a donation. I'm gonna give you some money. I'm going to get them with the understanding that I'm going to serve them out to the community. And I've got them on a cheap external hard drive, and I'm serving them for free. So they're going out on my father-in-law's cable box. So,
That'll take us a couple weeks to get.
yeah. So first of all, you're going to need a lot. When and if you go get these files, you're going to need a lot of space. It will take you a while to go because I serve it so slow. Though with torrent in a swarm, the more people that go to get it at the same time, the faster everyone gets them. So over time, other people might decide to seed and join in, at which point you're effectively downloading from the swarm, and the swarm is downloading from me. So all I have to do is effectively download it one time, taking 1/1,000th of the file to 1,000,000 people, and then all of a sudden 1,000,000 people are sharing it together. So torrent tends to speed up over time if everyone goes and gets it at the same time. If you do it in the first 2 weeks and then stop, and then Adrian goes and gets it, then we don't get the benefit of the community. Let's see what else we got. So these tools support rules. Rules talk about how we're going to mangle the password. We're not just going to feed in a list. We're going to feed in a list, and then I'm going to say, try elite rule, replace all the A's with @ signs. Add a number at the end, add a month at the beginning, add 2 numbers at the end, capitalize the first letter. I'm going to create all these different rules that I know from previous experience is how users manipulate passwords, right? So when you download the tools, you typically get the rules with the tool, but you can also create your own rules, and you should be aware that the community, in addition to sharing tools and tables, is also sharing rules, right? So you want to look out there in the world and see what new rules have people created that they're seeing some success with, and you can download rules. So the most obvious one is the Core Logic Crack Me If You Can Challenge from DEF CON 2010. After that was done, they did an analysis on how the winners cracked the most passwords, what were the most effective rules, what are they seeing with users. They have enterprise clients, Core Logic, so they can't release hashes and they can't release passwords, but they can release, because that's all confidential, but they can release rules. So you want to go get those rules. You want to be aware that that is another tool or resource that's out there. The typical best ones are packaged with the products, but there's more stuff out there. And they typically are compatible across products. So OCL Hashcat and John the Ripper are typically a 1-for-1. You can use the rule in the same place, same syntax. Crypto Haze, Multiforcer, you tend to have to tweak it around. But you can look at what this rule does in John the Ripper and say, okay, I want to write a rule for Multiforcer that does the same thing. Trying to speed this up a little bit. Word lists. This is another collection thing. People say, oh, I have to go get the latest and greatest word lists. If you go out to the web, which I did in the last couple weeks, and I was going to try to have this here to distribute, but it did not make it. You want to download a bunch of word lists. What are you going to get? You're going to get about 20 gig of compressed files from over 100 to 200 websites, somewhere that range. And you're going to get a massive duplication of effort. A lot of those are literally the same file being hosted in multiple different sites. So I deduped the compressed files, and then when you explode the remaining unique compressed files, you explode those out, you get a massive duplication of the uncompressed data, and you undupe that, and you end up, you started off with like 3,000 files for 20 gig, and then you delete all the duplicates and you uncompress it. Now you've got a smaller number of files, then you uncompress it, now you still have 3,000 files of 20 gig. And then you dedupe that, and you work your way down. And what you find out is that the vast majority of this stuff is relatively small. Someone has created a word list of movie titles, and the whole thing is under, let's say, 10K. It's It's microscopically small. It's too small to be a word list. I think we can probably safely say that a word list, one of the things that the rules do is they compare words with other words, right? So we're going to say, try two words together. Well, that's not going to work if your word list is too small, right? So you want to have at least some mass in there, and if your word list has 500 entries, that's too small. There's no way that that's going to be effective. You might accidentally hit something, but there's no reason why you do it. By the time you load it up and start the software and blast through, we're doing 8 million tests a second on the GPU, and you're testing 500 words, that's not going to work. So you want to be able to bring together at least the most obvious. So think about Wikipedia. Take every word on Wikipedia. That's a good starting point. Take every word in the Oxford Dictionary, and take every word in every language, put all that stuff in there. Famous people, any type of real data that you can find that looks comprehensible to a human, put it in. And you're probably going to get to about 50 to 100 meg of data. That's a good starting word list, right? But if you get, and if I add some noise into that, if I add into that list a completely random password, well, I'm going to waste some time. I'm going to waste 1/8 millionth of a second, testing that random password, which is really noise. But that's not a big deal unless my entire list is noise, right? So somewhere in all this data, there are lists that are closer to the 5 to 10 gig range. And I would suggest that that list is mostly noise. There's not enough human recognizable data in there that could be good. So coming out of this, I'm going to be adding to my website as well a series of word lists. So let's see what else we have. So there are two different types of word lists that you'd want to get. You don't want to waste a lot of time running a 10 gig word list before you've run a 100 meg word list if I tell you that 100 meg is roughly the right number. So, so you could have a mutually inclusive word list. I could say, give me a small, medium, and large. Large is 10 gig, small is 100 meg, and medium is going to be somewhere in there. But because some of the rules run words against words, let's say medium contains everything that was in small and more, and large contains everything that was in medium and more. Because you'd want to step and run small. Once you've taken out all of those hashes, you're cracking 6 million LinkedIn hashes. Once you've tested all of that, then you run medium on what remains, because it's now a smaller list, so it runs faster. And then you take large and run that on what remains. Recognizing that in large, there's probably a lot of noise. So that would be an inclusive version. You might be doing a application specific. Typically the application passwords have less word mangling rules, so the software for those. So then you'd want to do an exclusive thing. It's like, let me run all of the small first, then I need a version of medium that is bigger but does not include small, so I'm going to run that second, and then I've got large, which doesn't include anything that was in small and medium. So when I come out with this word list, you'll see it separated both ways. Be an inclusive, small, medium, and large, and I'll probably break it down to 4 or 5 different categories. I don't know what I'm going to name them yet. Gargantuan and enormous or something. And then you'll see an exclusive version of the word list. And those will be available, and last step is sort of some work to be done. What would be very interesting to know for those word lists, we'll have to take them and run them against some of the big databases, LinkedIn or Gawker or whatever, and actually create some performance statistics. Here's how much noise is in large that's not in medium. How much of a waste of time was this one, right, relative to this other one? So in other words, this one captures 60% of the passwords, this one gets 67, and this one gets 78. Well, now you have sort of a mathematical representation of, oh, well, this one takes 500 times longer. So we're going to take 500 times more processing time but we're going to get 18% more passwords. So now you sort of know, and you can make a business decision about whether or not you want to run that. So I'm going to be coming out with the word lists on my site, and that should happen within the next 2 weeks. Another thing is right now, none of these word lists were in Unicode. I don't know why that is, but there's, back in 1994, multiple people must have done, it was like Swahili, Yiddish, German, Spanish, Portuguese, every different language that you can think of has been dumped down into multiple word lists. So I can create a German word list, I can create a Russian word list, I can create a Chinese word list, and they're all in ASCII lowercase Latin characters, so which just makes no sense to me. That's not how those people are using those systems, and eventually we're going to have software that supports Unicode. You're going to want to have Unicode word lists. So that is something that, it's like anyone could pick up that ball who sort of knows how to get into and read those sites. All you have to do is fire off a word list creation tool, hit those sites, start downloading words and adding stuff, but capturing that Unicode data, and you'd have that would be a pretty good hacking project for anyone could do that right now. I know he wants to end, but I'm going to do Q&A. Anyone have any questions? Yes?
Would word lists be an effective attack on multi-word randomly generated passwords?
So one of the word lists that I dropped out of there because no one's using it is you can actually create a passphrase list. So, but what we're doing and how this all works is I watch what users do, I watch what passwords they're creating, and then I create a rule to go do that. So I think it was, everyone know XKCD? XKCD, some people, okay. XKCD said, it's like, why don't you just add, like 4 random words, like bucket, dragon, fire tree. It's like, oh, that's pretty easy to remember. Bucket, dragon, fire key. That could be my tree. That could be my password, right? Any 4 words, right? It's like, well, I'm going to make a rule that tests 4-word words, combinations of words. And there's only like 50,000 words in the Oxford Dictionary. So actually, that rule is going to run real fast, right? I mean, if you had a significant subset of users choosing a four words from the dictionary, that's 50,000 to the 4th possibilities. That's too small. That's like way too small. All right. Now, what if you had a whole sentence, right? Like to be or not to be? That is the question. So you throw that together. Well, now brute forcing that by testing all combinations of possible words. I don't know how many combinations there are, but now we're at 50,000 to the 12th. That's not going to work, right? That's a lot bigger. But you didn't pick 12 random words, right? You picked to be or not to be. That is the question, right? That is a pretty obvious password, right? If we're doing passphrases, like everyone's going to choose that. It was the best of times, it was the worst of times. So I'm going to make a database of all that stuff, right? And there's going to be a relatively small number of obvious quotes that people are going to choose. And I can go get quote databases all day. That's never going to get big enough. So you might do better by, it's like to be or not to be, that is the question, tree, fire, dragon, whatever, and stick something random at the end of it. Now it gets a little bit more complex. But yeah, anything that you can think of as a rule, anything that you can think of as a way that users are going to solve this problem of remembering too much complexity, I'm going to undo as a rule. And that's why passwords need to be dead, because users cannot remember the complexity necessary. Yeah.
What would you do to crack a password that would have 50 characters, special symbol, and it was like QFYZ?
So we can't, 50 characters, including uppercase, lowercase, numbers, special characters, etc., totally random. I can't crack that. There's too much complexity in that. But you can't remember it.
I look at the post-it note and it's there.
So the thing is, you're not going to do that, right? Unless you take that out and you write it down somewhere, right? And writing it down is a viable option for users, right? Now my password is as secure, let's say, as my wallet, right? I'm 50 years old. I've never lost my wallet. That's pretty good, right? People lost a couple $1,000s in Bitcoin last week, right? But I've never lost my physical wallet. So, I mean, writing it down on an index card and putting it in your wallet is not the worst plan in the world, right? So that's a possibility. Yeah, go ahead.
So what do you think about the systems to make passwords slower so you can only check like 10 a second?
Right. So one of the things when we talked about, hashing, I say I could, SHA-256 it, then MD5 it, then SHA-1 it, then SHA-256 it. Microsoft Office 2010, SHA-1s, well, it creates this special thing by salting the password with a unique identifier in the document so that every document has a different identifier or salt in it, right? But we take password, document identifier, and the document identifier is public, right? It's part of the encryption, so we know what it is, right? And then we SHA-1 that, and then we do it 100,000 times, right? And SHA-1 takes a little bit of time to run, so it slows it down. Now I can only check on a CPU Microsoft Office documents one every 50. I can only do 50,000 tests per second. No, I'm sorry, on a CPU, 1 test per second on Microsoft Office because I'm doing 100,000 SHA-1s in order to do 1 test. On the GPU, obviously, that would speed it up. I can also put it in the FPGA, and that would speed that up. But yeah, just do it 100,000 times. That definitely makes the secure, to the user, you didn't notice that it took a second to log into your Excel spreadsheet. It's like you lost that time. You blinked and it went away and you don't care, right? But to a brute force attacker, that's a big, big deal, right? It dramatically slowed down what I can do. So I would say that is an effective security control. I think that points to a lot of what John was talking about is, it's like, look, we can break into a lot of things, but there's an assumption here that stuff was broken already, right? That was something that you could do, right? It's that there was a mechanism that you could do to sort of slow things down for me that doesn't injure the user, but injures the password cracker. So that would be an effective control. And yeah, why stop at 100,000? And by the way, why make it an obvious number like 100,000? It could be 100,049, right? I am never going to figure that out, right? How am I going to know it's 100,049? So anyway, any others? Questions? Thank you very much.